everyone, I'd like to do an example of an application involving a shifted exponential function. So the idea here is not that you can perfectly draw out every detail of these really messy ones, but that even without a calculator handy, you can do a pretty decent job of getting a rough sketch. And if you at least have a scientific calculator handy, you can do a pretty good job of getting a couple of points labeled. Okay, so this function is supposed to model how quickly a bakery worker can decorate cakes after T days on the job. So I imagine they're probably getting faster as they go. So I kind of have an idea in my head that we're increasing here. I don't know if I think it'd be more and more quickly, but we'll find out. So looking at this, we're supposed to sketch a graph. And again, with E in the mix, I'm not going to do a bunch of crazy transformations, but I'm going to distribute that 10 through because that looks a little weird. And if you like it better, you can even rearrange the order. For some people, if I write that 10 out in front, it doesn't look as much like vertical shift, but that's what it is. So that's a shift up. And I also have both flips over, what is that one? That one's x-axis, flip upside down, and y-axis. And then I'm multiplying my t by 1/4. So that's a horizontal transformation. That's affecting my x's, and it will do the opposite. So that's actually horizontal stretch by 4. And what am I missing? I also have a vertical stretch by 10. So if I'm just thinking rough sketch on this, I'm starting with e to the x, which is exponential growth. I flip it both ways. So upside down would give me this. And then if we flip the other way, we get this shape. So hold on, let me sketch just that. So I'm expecting something that comes up to its horizontal asymptote and levels off. So that's new. That's not the way the parent shape works. But when you flip upside down, you can get that shape. So that is my double flip. I also need to stretch both directions. So that really doesn't change what this looks like. It just changes my scale. Everything's a lot bigger. So instead of this being at like -1, it's going to be at -10, things like that. So just imagine this shape, only things stretched out bigger both ways. And then a really important one is I need to shift up 10. So now I'm going to have an asymptote way up here, and I'm going to be in some way coming up and doing this. So to start my actual graph, I'm going to sketch that asymptote at y equals 10. I can already say that I don't want to see anything but quadrant 1 here. That's why I've drawn it this way, because I don't want to see negative cakes per hour, and I don't want to see negative days on the job. I don't care what was going on before they started the job, and we're not undecorating cakes, I guess is maybe what negative cakes per hour is. A really helpful point here would be your y-intercept, because I want to know where does it cross. So I'm kind of using a combination of kind of older ways of sketching graphs and transformations to help me figure out what's going on with a fairly complicated function. So if I check out what is f of 0, I get 10 times 1 minus e to the 0, which is also 1. Which means I'm actually getting 0. This thing goes through the origin. And you could also have gotten that by following your y-intercept through the transformations, but I think this was probably a quicker way to do it. So I'm getting this as a pretty decent rough sketch. If you have a scientific calculator, I think it would be great to maybe plug in one more point. Maybe I want to know what's going on after a month, so 30 days on the job. When I do that, I get 9.994. Hold on, 30 should go first there. 9.994. So I'm already getting so close to 10 that in the real world we would just about just round that up to 10 and say that we've hit that maximum of 10 cakes per hour. So we'll get into this in parts in a minute, but there is a point at which we say realistically we don't care about that 0.000001 part of a cake. So I don't know if that was super helpful. Maybe if we check around 1 week to kind of see if we're curving up at the right rate or not, it would be interesting. But again, pretty good sketch. This gives me a decent idea of what's going on. Okay, and then we have a few questions, and we've maybe already answered some, and we maybe haven't already answered others. We'll see. So first question, how many cakes can a newly employed worker decorate in an hour? I would interpret this as day 0 on the job. So personally, I'd say I'm interpreting 0, 0, and that they can't decorate any when they very first start. It isn't super precisely worded. I could see someone saying like day 1 of the job maybe, but I would interpret that as brand new, walking on the job, and the graph says we're going through 0, 0, so they can't decorate any cakes. The next question is, after 8 days, how many cakes can a worker decorate? So we can just plug in. So again, this would have to be at least a scientific calculator problem. We have 10 minus 10 e to the negative 1/4 times 8, so negative 2. And I got approximately 8.65 if I round it. So that's cakes per hour. And that I could take back up here. So let's see, 30, 20, 10. I mean, where I put my point isn't far off. So this should be at 8.65. This was 5, so maybe it's a little bit low, maybe a little bit closer to around here, so I might not have been quite steep enough, but you can see that I still got enough to get a pretty good general sense of what my graph looks like. So you can use more points, but generally a somewhat rough sketch is fine here. So that was 8 days, 8.65 cakes per hour. And then last question, how many cakes can a very experienced worker decorate in an hour? So this is basically asking the horizontal asymptote question. As more and more time passes, what's happening to their rate? And the answer is it's getting infinitely close to 10, and for almost any real-world situation, infinitely close is close enough to say equal to. So I would say a very, very experienced worker can decorate 10 cakes per hour. That is the maximum that we're going to hit. Technically, the graph never hits it, but realistically, 9.9999999 cakes per hour, we would call it 10. So that is okay for you to do. All right, so just think carefully about getting this rough shape. I think that's really important. That's probably your most important skill for heading to calculus, is not drawing an incredibly perfect graph, but drawing, or at least having a picture in your head of a very good rough shape.